The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. Lesson 19, Geometry, the circle. This is continuation of work on the circle. In this lesson, we will continue to solve geometric problems using theorems related to the properties of the circle. A quadrilateral RSTU, whose vertices lie on the circumference of a circle, is a cyclic quadrilateral. In a cyclic quadrilateral, the opposite angles are supplementary. That is, if we add angle R to angle T, we will get 180 degrees. And so, for the other pair of opposite angles. Here is more about a cyclic quadrilateral. In a cyclic quadrilateral, the exterior angle is equal to the interior opposite. Look at the diagram. At S, there is an exterior angle when RS is extended. So you have an exterior angle. The interior opposite to that will be the angle at U, which is named A. So the angle at U, A, is equal to the angle A at S. Note, a quadrilateral is cyclic if a pair of opposite angles are supplementary. And that will always be the case if it is cyclic. Can you identify the equal and supplementary angles? What can we say about the lengths of two tangents from an external point to the point of contact on a circle? If from a point outside of a circle, tangents are drawn to the circle, then the two tangents are equal in length. Notice the diagram there. You have two tangents. They are equal in length and they are marked. And any time you have a situation like that, you always conclude that the two tangents are equal. They also make equal angles with the chord joining the points of tangency. That is, if we notice that heavy line joining 2 points on the circumference, and you notice A at 1 making an angle there with it, angle A is equal to angle A, the base angle of the isosceles triangle formed by the two tangents. Let us work this problem. The diagram below, not drawn to scale, shows a circle center O. The lines BD and DCE are tangents to the circle, and angle BCD is equal to 70 degrees. 70 degrees is marked on the diagram there, you can see it. You are required to calculate 1, angle OCE, 2, angle BAC, 3, angle BOC, 4, angle BDC. Question taken from CXC June 2005. Here's the solution. First part, angle OCE is equal to 90 degrees. How we arrive at this? The tangent ED is at right angle to the radius OC, drawn from the point of tangency. You recognize that. The second part, angle BAC is equal to 70 degrees. Reason? The angles between a tangent to a circle and the chord through the point of contact are equal to the angles in the alternate segment. That is, angle BCD is equal to angle BAC. The third part, angle BOC is equal to 140 degrees. Reason, angle BOC is equal to twice the size of angle BCD. The angle between a tangent and a chord drawn from the point of tangency equals 1/2 of the angle at the center subtended by the same chord. Solution to the fourth part. Angle BDC is equal to 40 degrees. Reason, BDC is an isosceles triangle, so we have angle DCB equal to angle DBC, which is equal to 70 degrees. Angle BDC is equal to 180 minus 2 times 70 degrees, which will be 180 degrees minus 140 degrees, which will give us 40 degrees. Here is the problem for today. The diagram below shows a circle, center O. LMNR is a tangent to the circle. LSOP, NOQ, and MSQ are straight lines. Angle SPN is equal to 35 degrees. Calculate giving reasons for each of the steps of your answer. That is, find the value of angle SON. Second, angle NMQ. Third, angle SNM. Question taken from CXC January 2005. The solution to the problem given in the last lesson. Part 1. Angle ACB is equal to half angle AOB, which is equal to 65 degrees. Reason, the angle between a tangent and a chord drawn from the point of tangency at the center subtended by the same chord. The second part, angle CBD is equal to 30 degrees. Reason, of a circle standing on the same arc or chord are equal. In this case, angle CBD is equal to angle DAE, which is equal to 30 degrees, and this is given, not written in the diagram, but it is given in the problem. The solution to the problem in the last lesson continued here. The third part, angle AED is equal to 85 degrees. How we arrive at this? Angle BEC is equal to 180 degrees minus 30 plus 65 degrees, which will give us 8. Angle BEC and angle AED are vertically opposite angles. Therefore, angle BEC is equal to angle AED, which is equal to 85 degrees. This brings us to the end of today's program, CXC Mathematics in Focus.
Boys and girls, in today's lesson, we will look at some problem areas in grammar. Firstly, subject and verb agreement. Modifiers between subject and verb. Let us look at this sentence. One of the most dangerous criminals is in the officer's house. The subject in this sentence is one, and the singular verb should not be affected by the modifier, the most dangerous criminals. A short series of courses has been suggested. The subject in this sentence is a, and the singular verb should not be affected by the modifier short series of courses. Sentence C reads, the estimates submitted by one contractor interested in the project appall us. The subject in this sentence is estimates, and the plural verb should not be affected by the modifier submitted by one contractor interested in the project. Parenthetical phrases between subject and verb. The verb is not affected by the parenthetical phrases between subject and verb. The senior officer, as well as his advisors, has arrived. In the example above, the subject, the senior officer, is singular, so the singular verb is used. In sentence B, the sergeant, along with 2 constables and 2 secretaries, is under suspicion. In this example, the subject, the sergeant, is singular, so the singular verb is used. Subject and complement of different number. The verb is not affected by its complement. Let us look at this example. His greatest problem is his children. In the sentence above, the complement of the verb, his children, is plural, but the subject is singular, so the verb remains singular. In another example, his children are his greatest problem. In this sentence, the complement of the verb, his greatest problem, is singular, but the subject is plural, so the verb remains plural. The main reason he looked so ill was the late hours he has kept. In this sentence, the complement of the verb, the late hours he has kept, is plural, but the subject is singular, so the verb remains singular. Let's take a look at compound subjects. The compound subject is joined by and identifies 2 persons or 2 things, so the plural verb is used. The owner and the editor determine the policy of the paper. The compound subject joined by and identifies 2 persons, so the plural verb is used. The bed and table cost too much. In sentence B, the compound subject joined by and identifies 2 things, so the plural verb is used. C. The owner and the editor, Mr. Smith, determines the policy of the paper. In this sentence, the compound subject joined by and identifies 1 person, so the singular verb is used. Peace and quiet was all I wanted. In this sentence, the compound subject joined by and identifies 1 thing, so the singular verb is used. Boys and girls, we'll now take a look at compound subjects joined by nor, or but. Tom or Terry takes the books home. The subject closer to the verb is singular, so the singular verb is used. Neither pie nor cake tempts me. The subject closer to the verb is singular, so again the singular verb is used. The boys or the girls. The subject closer to the verb is plural, so the plural verb is used. Neither Louis nor the lawyers were there. The subject closer to the verb is plural, so the plural verb is used. Not only the father, but the boys refused to clean the drains with a positive and a negative part. The subject closer to the verb is plural, so the plural verb is used. Mathematical computation. It is correct to use the singular or the plural with mathematical computation. For example, 5 and 5 is 10. 5 and 5 are 10. 2 times 3 is 6. 2 times 3 are 6. Indefinition. None or any can take the singular or plural verb. For example, none of the applicants were German. None of the applicants was German. None works so faithfully as he. None are expected from that district. Are any of you going to the show? Any of the times is unsatisfactory. Anybody, anyone, each, either, everybody, neither, nobody, no one, somebody, can only be used with the singular verb. For example, each of the men takes home several bunches of plantains. Everybody in the tents was awakened by the crash. Neither of the clocks keeps accurate time. Collective nouns can be used with singular or plural depending on how they are used in the sentence. For example, the band is going to Suriname this year. This time the band refers to one unit. The band, as usual, were strolling into the auditorium in groups of 2 and 3. This refers to the members of the band. The whole family is here refers to one unit. The family are all attending different churches refers to the members of the family. The platoon are moving their knapsacks. They are getting ready for a mock change. Refers to the members of the platoon. A number and the number. The plural verb is used with a, while the singular verb is used with the. Example, a number of cars were already there. The number of errors was surprising. Some, all, more, most, half, third, part can be used with both singular and the plural verbs depending on their use in the sentences. Let us look at some examples. Some of the material has faded. It is one piece of material, so the singular verb is used. Some of the buns are stale. There are many buns, so the plural verb is used. Words of measure, length, distance, amount, weight, take a singular verb once it, they refer to a single unit. 6 weeks is a long time to wait. 4.5 acres does not provide enough space. $10 was too much to pay. Boys and girls, these are some of the errors that are frequently made in grammar. Try to read and practice to get them right. On behalf of the team, Bibi Ali, Parmeshwar Lal, and Ron Chichester, I'm Ingrid Pong saying thank you for viewing.
The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. Lesson 20, Measurement, and we are looking at perimeter and area. In this lesson, we will find the perimeter and area of plane shapes. First, we will find the perimeter of polygons and the circle, and later we will find the area of triangles, rectangles, parallelograms, trapeziums, circles, and geometrical shapes on solids. Here are some formulae for finding perimeter of plane shapes, along with examples of calculation of perimeter. In the first column, we have the shape. In the second column, we have the formula. And in the third column, we have an example for each. In the first shape that we have there, it's a rectangle. The rectangle has length, which we label as L, breadth labeled as B. So the formula for finding the perimeter of a rectangle of length L and width B is given as P is equal to 2 times length plus breadth, or could be expressed differently as 2L plus 2B. If you're given that L is equal to 12 cm and B is equal to 6 cm, the perimeter is equal to 36 cm. That is 12 plus 6, which will give us 18. Double 18 will have 36. So the perimeter is 36 cm. The next shape in the first column, you can recognize that it is a square. In a square, all the sides are equal and all the angles are right angles. So if one side is given as S, it is understood that each of the other side has a length S. So there will be 4 S's going around. So the perimeter of a square, which is given as P is equal to 4S, that is 4 times S. In the example, if S is equal to 14 cm, then the perimeter is equal to 4 times 14 cm, which will give us 56 cm. So the distance around that square is 56 centimeters. In this example, we have a circle. Circle has a radius r. The formula for finding the distance around the circle, that distance around has a special name which we call circumference. We represent circumference with c. So the circumference is calculated as 2 pi r. 2r will give us one diameter. So in some of the textbook you would see that the circumference is expressed as diameter times pi, or pi d. In this case we are expressing it as 2 pi r. Pi is given several approximated values. Some books will use 22/7. Some will use 3.14. Others will use 3.142. In this case, we are using the value for pi as 3.142. So if we are given that r is equal to 14 cm, that is the length of the radius is 14 cm, the circumference is equal to 2 times 3.142 times 14, which will give us 87.976 centimeter. That's the distance around the circle. Now look at the fancy shape given in the next one. It's looking like a washer cut in two. So there's an inner radius and an outer radius. Now, can you now find the formula for the perimeter of this shape? You need to do some serious thinking how to arrive at the formula. But this is one for you to try. Let us find the areas of some common shapes. Again, we look at the rectangle. The rectangle would have, as in the previous example, a length and a width. Sometimes we call the width the breadth. The area is given as length multiplied by breadth. So if we're given that L is 12 cm and B is equal to 6 cm, the area is equal to 12 times 6, which is 72 cm squared. And note this particular unit for measuring area. Area is measured in square units, and in this case the area is expressed as 72 centimeters squared. In the next example, we have a square there of side S. The area for the square is expressed as A is equal to S squared, that is S multiplied by S. If S is given as 14, note that the square there should not be there. A is equal to 14 times 14. S is 14, so the area is 14 multiplied by 14. And when that is multiplied, we'll end up with 256. And the unit would be centimeter square. So the area of that square is equal to 256 centimeters square. Let's look at the circle. The formula for finding the area of a circle of radius r is equal to A is equal to pi r squared. That is pi multiplied by r multiplied by r. If r is equal to 14 centimeter, then the area can be expressed as 3.142 times 14 squared. When worked out, will give us 615.8 centimeters squared. So the area of that circle is 615.8 centimeters squared. Now, you are asked to find the perimeter of this half a washer as shown on the screen. The inner radius is R and the outer radius is big R. Can you find a formula to find the area given that big R is 21 cm and little r is 14 cm? Now the cuboid. You would recognize that a cuboid is sometimes classified as a rectangular solid. Take a single vertex as shown there. From that vertex, we have emanating from it length, which is given as L, breadth given as B, and height given as H. You're asked to find the total surface area of the cuboid. Now, the formula for finding total surface area is equal to A is equal to 2 into L times H plus B times H plus L times B. Now, multiplying LH will give us the area of the face, the front. B times H will give us the area of the right hand corner or the right hand side. And L times B will give us the area of the bottom. Now that will only be half the area of the total surface. To get the total area, we multiply by 2. So in the example given, you're told that L is equal to 15 cm, B is equal to 12 cm, and H is equal to 10 cm. The area A is equal to 2 into 150, that is L times H, plus 120 plus 180 centimeters squared. Note, area is measured whether it's plane or solid. It's measured in centimeters squared, and in unit square, in this case, centimeter square. When we work that sum out, we'll have 900 centimeters square as the total surface area of that cuboid. Let us now find the surface area of some common solids. First, let us look at the cylinder. On the cylinder, we have the radius of one circular end, and that is given as R, and the height of the cylinder is given as H. To find the total surface area, we'll have to add the area of the top, the area of the bottom, and the area of the curved surface. Let's get the area for the top. The formula for finding the area of the top is pi r squared. The area of the top is equal to the area of the bottom. So the area of the bottom is also equal to pi r squared. The area of the curved surface is equal to 2 pi r h. That's a formula for finding the area of the curved surface only. So the total surface area is equal to the sum of those three parts. That is the top, the bottom, and the curved surface. So the total surface area is equal to 2 pi r squared, that's the top, plus 2 pi r h, which will give us, 2 pi r squared will be top and bottom, and 2 pi rh will be the curved surface, which can be expressed from our factorization principle as 2 pi r into r plus h. Let's see how an example will work out. We are given that r is equal to 14 centimeters, h is equal to 20 centimeters. We can now find the area of the top. The area of the top is equal to 3.142 times 14 squared. When that is worked out, we have 615.8 centimeters squared. The area of the top is the same as the area of the bottom. So the area of the bottom is 615.8 cm square also. The area of the curved surface, when worked out, will give us 1759.5 centimeters square. So the total surface area will be 615.8 plus 615.8 again, plus 1759.5, which will give us a total surface area of 2991.1 centimeters square. Now the sphere. The radius of the sphere is given as r. The surface area of a sphere is given by the formula A is equal to 4 pi r squared. Let's see the example. R is equal to 28 centimeter. So the surface area is equal to 4 times 3.142 times 28 times 28. When you plug these values in your calculator, you will end up with a result 9,853.312 centimeters square. Here is your problem for today. The diagram below, not drawn to scale, shows a prism of length 30 cm. The cross section WXYZ is a square with area 144 centimeters square. Find the total surface area in centimeters square of the prism. This question is taken from CXC January 2007. This is the problem given to you in the last lesson. The diagram below shows a circle, center O. LMNR is a tangent to the circle. LSOP, NOQ, and MSQ are straight lines. Angle SPN is equal to 35 degrees. Calculate, giving reasons for each step of your answer. Angle SON, angle NMQ, and angle SNM. This question is taken from CXC January 2005. Here is the solution. Angle SON is equal to 70 degrees. The reason? Angle at the center doubles that at the circumference. The second part, angle NMQ is equal to 90 degrees minus 35 degrees, which will give us 55 degrees. Reason? Tangent and radius meet at 90 degrees and angles in the same segment are equal. The third part, angle SNM is equal to 35 degrees. Reason? Angle made by chord and tangent equals that in the alternate segment. This brings us to the end of today's program of CXC Mathematics in Focus. On behalf of the production team, Rajvanti Permal, Peter Wins, Joseph Mackenzie, let me invite you to join us tomorrow for another program CXC Mathematics in Focus.
In this lesson, we will look at some of the errors in the English usage that are commonly made. These errors are to be avoided in our speech and writing. We will also work through an exercise based on the above. We will use the format that sometimes appear in the CSEC Paper 1 of the English A examination. Redundancy. Redundancy in speech or writing is considered an error. It is the unnecessary repetition of an idea which contributes nothing new to the meaning the writer wishes to convey. Let us look at this example. The driver reversed back the car and consequently caused an accident. The words reversed and back convey the same idea. This is a common error and we must avoid it. Example 2. Without warning, unexpectedly it began to rain. Again, without warning and unexpectedly convey the same meaning. Clichés are expressions, metaphors, similes, and proverbs which have lost their original freshness and power through overuse. Some similes and metaphors which have originally made writing more vivid and picturesque have now by overuse become clichés. You should avoid using clichés by replacing them with lively and interesting expressions. Here are some examples of clichés you should avoid when writing or speaking if you are to use language in a creative, original, and interesting way. In this day and age, make hay while the sun shines, break the ice, turn a blind eye, root of the matter, in a nutshell, burn the midnight oil, ghost of a chance, fell on deaf ears, put your hands to the plow. These are just a few of the hundreds of clichés that are to be avoided. Misused or mixed metaphors. When one metaphor follows too closely upon another, the result can be confusing and illogical. Let us follow this example. If we put our hands to the plow, we would guide our ventures into deep waters and eventually reach the peak of our aspirations. You will notice that the basic comparison is not sustained. The plow, the deep water, and the peak are metaphors that have no direct link or meaningful connections. There is no continuity in the basic comparison or metaphor. This causes confusion in the mind of the reader or listener. The meaning of the sentence is not logical nor clear. Another error that appears frequently in language use is the misrelated participle. You must remember that no matter how commonly it is used, it is wrong and should be avoided. The participle introducing a phrase must relate to the relevant noun or pronoun in the sentence. Here is an example in which the participle bears no logical relationship with the main subject. In such a case, the sentence must be restructured. Flowing down the mountain, huge boulders worn from rocks were deposited. The participle flowing relates to huge boulders in the sentence. The writer's intention is to show that while the stream was flowing down the mountain, it deposited huge boulders. The sentence should therefore be written, while the stream was flowing down the mountain, it deposited huge boulders worn from rocks. These are all errors in English usage, and they are tested in CSEC English A Paper 1. The following exercise is a sample of how these areas may be presented in the examination. Usage. Some sentences are unacceptable because they contain one of 4 kinds of error. No sentence contains more than one error. Some of these sentences are acceptable as they stand. Mark the letter that best describes each sentence. The letter A we would write if the sentence is too wordy, repetitive, or contains redundancies. B if the sentence contains cliches or misused metaphors. If the sentence is incorrect grammatically or faulty in diction. D if the sentence is acceptable as it stands. The first example. The student's opinion vacillated to and fro during the debate. The next, walking on the seashore, birds perched on the rocks far out at sea. 3. All her entreaties fell on deaf ears. 4. Personally, I think that technological progress has led to moral decline in our society. 5. You must put on the armor of truth before you launch into the race of life. 6. I will not expect her invitation. In your examination, you are likely to be given a comprehension exercise. Now, students, the student's opinion vacillated to and fro during the debate. The answer to this is obviously A. There is redundancy in the sentence. We can remove the phrase to and fro without altering the meaning. Clearly, to vacillate means to sway to and fro. Walking on the seashore, birds perched on the rocks far out at sea. The answer is C, incorrect grammar. This sentence contains a misrelated participle and should be reconstructed to read, while I was walking on the seashore, I saw birds perched on the rocks far out at sea. All her entreaties fell on deaf ears. The answer here is B. Fell on deaf ears is a cliche. This phrase is stereotyped and overused. It may once have had a fresh and distinctive significance, but through repeated use, it has lost its original freshness. Try replacing this with a fresh expression of your own. Personally, I think that the technological progress has led to moral decline in our society. Again, the answer here is A, redundancy. We need not add personally. This is very commonly used. However, it is still incorrect. You must put on the armor of truth before you launch into the race of life. This time, the answer is B, misuse or mixed metaphor. Armor of truth, launch, and race of life are metaphors that have no direct links or meaningful connections. You will observe the comparisons are not sustained. This is illogical and will cause confusion to the reader. 6. I will not accept her invitation. The answer is C, and this time it is an error in diction, choice of word. It is obvious that the word should be accept and not accept. 7. In your examination, you are likely to be given a comprehension exercise. The answer to this question is D. The question is correct as it stands. Students, you must remember that correct items are sometimes placed among the incorrect set. Try to use your textbooks to practice some of these type of questions. Until the next time, I'm Ingrid Phone saying goodbye on behalf of Bibi Ali, Parmeshwar Lal and Ron Chichester.